this lesson, we would learn how to sketch a cubic function. And we are going to follow the following 5 steps. So step 1 is to find the y-intercept, that is where x is equal to 0. Step 2 would be to find x-intercepts, that is where y is equal to 0. There are 3 cases of x-intercepts. The first is where the cubic function only cut the x-axis once. The second one is 2 x-intercepts, where the one value is the cubic function going through the x-intercept, and the other value would be a turning point on the x-intercept. And the third type of x-intercept that we can get is where we have 3 intercepts, where the cubic function goes through the x-axis at 3 separate places. So don't get nervous if you only find 1 or 2 x-intercepts, or even 3. These are all different variations of the x-intercepts that you can expect to find. Our third step would be to find the local minimum and local maximum points. And remember, at the local minimum and local maximum, the derivative is equal to 0, or the gradient is equal to 0. Step 4 is to find the point of inflection, and the point of inflection is the point in the middle of the local minimum and maximum. And step 5 is to simply plot and draw function. So let us draw the following cubic function. Fx is equals to x cubed minus 3x squared minus 9x minus 5. Step 1, let us find the y-intercept. And we find the y-intercept by replacing x with 0. Therefore, the y-intercept is where x is 0 and y is negative 5. Our second step is to find the x-intercepts. Remember, we can either find 1, 2, or 3 values. And at this point, we are going to use the remainder and factor theorem, which we learned in previous lessons. So remember, I need to find a value for x which will make fx equal to 0. So if I substitute negative 1 into the place of x, it will make the equation equal to 0. Therefore, x plus 1 is a factor of fx. Now, we are going to rewrite or factorize fx. So x plus 1 is a factor, and our second bracket would be ax squared plus bx plus c. Remember, we solve a by taking x times x squared to find the coefficient in front of the x cubed, and that is 1. We find c by multiplying 1 with the value of c to get the constant value of negative 5, and in this case the c value is negative 5. And then we need to find bx. And in order to solve b, we use the negative 3x squared. So to solve b, I say 1 times x squared, x times bx, so I have x squared plus bx squared, is equals to negative 3x squared from the original equation. And then I solve b, and in this case, b is negative 4. Now we have x plus 1 and x squared minus 4x minus 5, and I can factorize the second bracket. So I have x plus 1, x minus 5 times x plus 1. And I notice I have a bracket that is repeating. So therefore I have 2 x-intercept values. x minus 1, and x equal to 5. Step 3 is to find the local minimum and local maximum. And remember, at the local minimum and maximum, the gradient is equal to 0. So here's the original function, and I find its first derivative. So x cubed. So if I derive x to the power 3, it will become 3x squared. Negative 3x squared would become negative 6x, and negative 9x would become negative 9. The negative 5 will fall away because it does not have an x next to it. And in order to find the local minimum and maximum, I place the derivative equal to 0. I notice that I can divide everywhere by 3. So I have x cubed minus 2x minus 3. I factorize, so it's x minus 3 times x plus 1. Therefore I have two values, one for the local minimum and one for the local maximum. One is x equal to 3 and the other is x equal to negative 1. I use these two values and I substitute it into the original fx function to find the y coordinate. So replacing 3 in the original function would give us negative 32, and replacing negative 1 into the original function will give us 0. Therefore, my two coordinates for the stationary points are 3 and negative 32, and negative 1 and 0. Now step 4 is to find the point of inflection. And the point of inflection is the middle between these two coordinates. The middle between 3 and negative 1 is 1. And the middle between negative 32 and 0 is negative 16. And this would be the point of inflection. Now we are moving to step 5, where we will plot the cubic function. So before plotting the cubic function, I start with the Cartesian plane. Remember to name the x and y axis. Then I plot all the coordinates given to me. So in step 1, the y-intercept was negative 5. In step 2, we found two x-intercept values, the one at negative 1 and the other at positive 5. In step 3, we found two local minimum and maximum values, or two stationary points. The one was at negative 1 and 0, and notice it is sharing the x-intercept. And the other was at 3 and negative 32. And in step 4, we found the point of inflection, the midpoint between these two coordinates, which is 1 and negative 16. Now, because this is a stationary point, we know that it's a turning point, and that stationary point will also be a turning point. So now I simply connect the dots. As far as possible, try and connect the dots with a curve. So by connecting the dots, I can see that this is the function of fx.